Hello everyone, this is Dr. Hassanzadeh and I'm going to explain transient analysis in Multisim for a basic LR circuit. As you can see, I have constructed a circuit with a 120 volt DC voltage and a key or a switch that I am using that uses the key A to open or close. And I have a resistor here, 1.5 kilo ohm, and a 60 millihenry inductor. So in order to see the transient waveform, you have to go to the simulate and go to analysis and then transient analysis. Okay, as you can see here, the initial condition, as you can see, it has many options like set to 0, user defined, or calculate DC operating point, or determine automatically. Automatically is the default value, but you need to set it to 0. So set the initial condition to 0 and then go to the output. Here you will have the different current and voltages in the circuit. As this is a series circuit, so all the components currents are equal. So if I have, for example, IL1 or IR1, it will show me the current in the circuit. So both of them are the same. If I want to plot the voltage across resistor, I have to use the expression because there are 3 components here, and I have to write, for example, add expression, and I have to write, for example, because the first node is 1 and the second is 2, so the voltage across the resistor will be V2 minus V3, right? So it's the voltage across resistor, and then I can say OK, and it will plot it for me. And the rest of the settings, you don't have to change it right now. The only important is that you set the initial condition to be 0 and hit simulate, and you will see that the different plots are shown here. I usually advise that you do not use multiple plots on one screen because it won't be into the scale, and it will not show you the correct waveform. So in the transient, just go analysis, transient analysis, and I only choose one plot. For the output, I prefer to see just the current of the inductor. So remove the other one and just simulate. So you will see just the waveform for the inductor, and the units are shown and everything is good. I usually advise to use this icon to make the white background, and there are different other options that you can use. You can use this one. So if you click on this one, it will show you the data points. It will connect all those data points, and it's always good to see what value these data points are, so you can use the cursor. As you can see, if you click on this icon, you will see the plot of the values of XY axis, and there will be 2 cursors that you can move, and you can point it to a point on the plot, and it will show you the value of X and Y. X is the time, and Y is the value of current here. And because there are two of these cursors, so you will see X1 and X2, which was the X of the first one, and you can see that there is a number on top of each cursor, so it will show you the values that you have. So you can move around and read the exact value of the plot. So use a white background, and also don't forget to click on this show data points icons, so it will show you the data points, and use a white background, and also use this icon to show cursors, so it will show the exact value on the plot. So you can easily measure the time constant or 5 time constant and what the voltage is at any point. So it's pretty much easy to perform this. So this is the transient analysis, and you will do the same thing for RC circuit. Just use the 0 initial condition in order to get this plot. There is another question that most students have, is that how to see the transient voltage when the switch opens. So in order to model that, we have to use a resistor across the switch. So I'm going to get another resistor from here and make it in parallel to the switch, as you can see here. And in order to simulate an open switch, so you have to use a large resistor here. So I make the switch open and I set this resistor value to a large value, say 1 mega ohm. So you have to use a capital M in order to get a 1 mega ohm. And I use initial condition for the current. As you have seen from the previous plot, the maximum current of the inductor will be 80 milliamps. So if I click on the inductor and I go initial condition, and I set it to 80 milliamp, so the current will be the initial condition or initial current of the inductor is 80 milliamps. So this is a case that the circuit has been working for a long time and the time constant has passed and the current is 80 milliamp passing through it. So when the switch is open, this current will flow through these two resistors and will decay to zero. But at the beginning, this current will flow through the large resistor, and you will see, because the switch has been opened, you will see a very large voltage across the switch, which is actually across the large resistance of 1 mega ohm. So we have to go to the simulate analysis, transient analysis, and this time analysis parameters, you have to user-defined initial condition. Okay, so you have to choose the option user-defined, and anything else, the output, I would like to see the voltage across the switch or across resistor R2. So you have to use expression. I'm going to use V1 minus V2, which is the voltage across the switch or across resistor R2. So I set this one and I simulate the circuit, and okay, so we should be able to see one plot, and as you can see, the voltage has reached a large value here. Okay, you can see that it has gone at the 0 point, it has gone to a very large value, because the 80 milliamp will go through the 1 mega ohm resistor, and you see that there is a, okay, I can use the white background and I can use this. You see that the peak value here has gone to even 25 kilovolts. So this shows that, and you should be able to zoom in here to see a larger waveform here. See, this is the peak value that we can measure, and as you can see, it has gone to about 31 kilovolt, which is 31,000 volts, right? So it depends on the simulation and a number of points that it takes for the simulation and amount of resistor and the initial condition, and you will see different peak voltage values in the simulation. And again, you can use the cursor, as you can see, in order to move it and measure the maximum value here. So here is the cursor. See, I move it here and it will show you the for example 17K value, as you can see here. That's pretty much the one for transient analysis, and you should be able to easily use it for any circuit. For the normal circuit, use zero initial condition, and initial condition is 0 for the normal circuit. But if you have to simulate like the circuit that I showed here, and you have to have a initial current in a inductor or initial voltage and capacitor, so use initial condition for your simulation and also use initial condition for the component on the circuit. Thanks. Let me know if you have any questions.